We've been working with OpenLDAP for quite some time, and certainly it would be helpful to know where logging information is stored, as well as how to configure it to tailor it to our needs. It enables us to debug when necessary and to keep track of the activities of the server. So let's move beyond LDAP search, which we'll revisit as we continue to grow our DIT and label a subsection for logging/debugging. The features should be self-explanatory, and they include the fact that OpenLDAP logs using syslog, and it defaults to local 4, and that's the facility local 4. Regardless of distribution, OpenLDAP seeks to log to local 4. So the question becomes, given your distribution of Linux, where does local 4 end up if it's routed at all? So we'll figure that out momentarily across the 3 operating systems that we're working with. But by default, OpenLDAP logs to local 4, which generally ends up in a file, and it includes LDAP searches. Let's just note, includes LDAP searches, as well as starts, stops, and miscellaneous information. Now we'll begin by looking at the SUSE 10 configuration, since this is our primary LDAP server. Local 4 on SUSE 10 is by default routed to varlog local messages. In fact, all of the local facilities within SUSE Enterprise 10 route to varlog local messages to this file. So you'll find, in addition to LDAP related entries, other entries for other local facility users. Doesn't mean we can't split local 4 out. We certainly can, routing it to its own file, such as a file named LDAP. But just know that if you're on a SUSE box and you're looking for LDAP related logging information, you're to search varlog local messages. Now the syslog configuration in SUSE is defined in etc, so syslog ng config is defined in etc syslog ng syslog-ng.conf. SUSE Enterprise Linux uses a different distribution of syslog. It's the new generation, next generation of syslog, which supports more meaningful logging and a method of tying various components together in an object-oriented manner, which subsequently allows us to perform things you can't do in plain old syslog, such as filtering messages based on the content of the message, not only based on the facility and or level. But nonetheless, syslog-ng is entirely compatible with syslog, so nothing much really changes other than the additional functionality that's provided. So it's configured in etc syslog-ng. Let's take a look at that file. And we'll do so on SUSE 2, which is the primary host. Let's find a window where we have that open. And in this case, none of them are open, so we'll SSH. And then we'll navigate to etc syslog-ng, where we have the syslog-ng conf file. A less of this file, and there's also an include file. This is the file that you should modify if you want to append to the original configuration, as syslog-ng imports, in addition to the main conf file, the conf.in file. So if you want to make changes, make them to the conf.in file, or carefully change syslog-ng.conf. So as we scroll through this file in search of the local facilities, we'll see it momentarily. It's defined as a filter for flocal. Syslog-ng makes use of various abstractions. One is the filter. A filter is bound to a particular destination, and a destination is bound to a log, which usually is the invocation and the marrying of the filter, which is tied to a facility, to a given destination, such as a file, a console, or perhaps a remote host. So here we see a grouping of f_local, which represents all of the local facilities supported by standard syslog. It just so happens that LDAP uses local 4. So we need to trace this document for instances of f_local beyond the definition of the filter. So we need to find where it's defined as a destination and then bound to the log grouping. So let's scroll through. We should see it momentarily. Destination for the f local. And we can also grep it out. And here we see destination local messages for var log local messages, and the log directive binds the filter f_local to the destination local messages. So this is where it all takes place. So this tells us that entries for LDAP end up in var log local messages. Let's navigate to that directory and tail the contents of local messages, where we see recent slapd entries. Now, as mentioned, if a search is performed, such as a recent search of the OU people, it's reflected in the config file, the default config file, as well as other entries such as connections and their connection IDs. Whenever an LDAP client connects to the server, a connection ID is initiated, is instantiated, and is reflected in the log file by default. Also, the client IP, the connecting IP, including the connecting IP's source port, is logged, as well as the destination IP address and port. When you see all zeros, that means IP version 4, followed by the port number 389. We see that a previous connection was closed. We see a new connection to bind, and the result, the exit status was 0, and the search that was performed. If you start and stop the server using rcldap, for example, stop followed by start, it will be reflected in the local messages file. Trail through looking for stops and start. Here we see slapd starting. This is after the stop. The tail only shows the most recent entries. So if we tail, let's say, the last 20 lines of local messages, we will see the stop as well as the start. And there we see slapd shutting down. Finally it stopped, and then it started. Now, on top of the syslog configuration, you may configure LDAP to log to the console using various levels. That's the debugging mode. Let's discuss debugging. This applies regardless of distribution. There are multiple levels which can be defined. The numbers range from -1 through 32,768, and they double each time. So let's show you what we mean. There are various log levels, and in fact there's an attribute, an option name log level, that can be specified in slapd.conf followed by an integer. The integer ranges, as I've mentioned, from -1 through 32,768. And each integer has a unique meaning. Let's go through those levels quickly. If -1 is indicated, whether on the command line when starting slapd or in the slapd.conf file, this turns on all debugging. So all debugging information is dumped to standard out. And in fact, we'll turn it on as we go along. Let's do it right now and restart the service. Now, the place to update the logging in SUSE for slapd is in etc sysconfig. Let's just note that. Update etc sysconfig open LDAP to adjust logging default or debugging default. And this is debugging to standard out, meaning the console with which you're connected to the slapd service that you've instantiated. So if you'd like to debug in your console window, which is often important and useful in the event of perhaps connection errors or configuration directive errors and so on, then you'll want to modify the appropriate startup file. SUSE and Red Hat Linuxes both maintain a separate file with startup options that are read by slapd. And that file, as we've mentioned, is an etc. So if we nano etc sysconfig, which is a general container, general directory for startup options for various daemons operating on the system. And if we navigate through this file, you'll see that there are various options concerning the features with which LDAP may start, such as LDAP secure, TLS, so on and so forth. The variable we're interested in is OpenLDAP slapd params. Let's copy it. This is what we want to update to reflect a new logging level. In here we indicate -d and the appropriate integer for the task at hand in the event that we want to log a specific functionality. If you want to turn on logging for all items, debugging for all items, then indicate -d -1 wherever your startup file happens to be. If you're using a different distro that stores its startup parameters for slapd somewhere else, wherever that somewhere else is, indicate as one of the startup parameters -d space -1 or whatever option you choose from the list that we'll present momentarily. On the Solaris side, since we currently don't have a startup script, we will stop it. We'll kill the process on the command line and restart slapd from the command line using the -d option, which will provide the same functionality. So in open LDAP slapd params, we'll indicate -d space -1, save the changes, reset our buffer, and then restart the slapd service. This will restart and will dump a considerable amount of information to the screen. All of the schemas that are read upon startup, so much so that it overruns our buffer, including whether or not the attributes are case sensitive and what values fulfill them in their nodes and so on. All that information is dumped to the screen. This represents all of the schemas that are loaded initially by the slapd.conf file. Each line of the slapd.conf file is reflected when you turn on all debugging. Line 17 reflects the PID file, and if there's an error with any of the steps when you have on the all debugging mode, it'll be reflected in your window, in your command window. So here we see line 17 processed successfully, otherwise we would have witnessed an error. An error would have been returned. Line 18, the arguments file, the file which contains the arguments with which slapd started. 21, module path, where to find modules to extend the functionality of LDAP. 42, access to the DN base, meaning the distinguished name base, if you connect as anonymous or anyone, you're able to read the contents of the directory information tree, and so on and so forth. ACLs are loaded, additional lines are read, the root password is not echoed to the screen, but it was processed, the directory where to store LDAP databases, what indexes should be defined, all the way through the end. And again, if there are any errors, you'll see it. Here's a full-fledged debug which returns to the screen a TCP dump like output. It's a hex dump of the start of the server. So this is with all debugging mode turned on. Now what else does this mean? If we execute queries against the server, let's type reset and execute an LDAP search. This is the level of verbosity that's presented whenever we run a command against the server, any command for that matter. And anything that's returned is dumped in hex form, as we see here. This represents users and OUs. This is linuxcbt1 from OU equals people. And if we scroll up, linuxcbt1 OU equals people. All of the attributes for that particular user are dumped to the screen, as well as additional information. So all debugging can be a bit noisy and isn't always desirable, but nonetheless, if you want to see everything that your slapd instance is doing in a console window, turn on all debugging. Now let's move on. There are additional levels. 0 disables debugging, or no debugging. So that's simply -d 0. Let's try this quickly. Sysconfig open LDAP. We'll search for -d and change it to 0. Then we'll execute an RC LDAP restart, and only upon the shutdown do we see debugging information, but when the server restarts there is no debugging information echoed to the screen. If we execute an LDAP search, just the general output shows up. If we tail local messages, information is still logged. The fact that we search the server is still logged. So the startup option -d has no impact on what slapd logs via local 4, which gets logged through syslog. Slapd will always log a minimum amount of information, such as the searches that were performed, if there were any connection errors, the sources and destinations of connections, whether or not connections were opened or closed, etc. That information is always logged. But as far as the console information, the debug information in your face on your TTY, in this case we're on TTY sudo terminal 1, you will be able to tailor how much or how little information is dumped based on the -d startup option passed into slapd. So beyond level 0, there's level 1. Level 1 turns on tracing. Tracing also produces a lot of connectivity and process calling information, but it's sometimes necessary. If, for example, you've integrated LDAP with some other process, let's say Samba or Bind DNS or any other process that's LDAP compliant, postfix, sendmail, etc., and you have some sort of inter-process communication problem, a trace might help you get to the bottom of where the communication is breaking down. Not necessarily only network connections, but perhaps the postfix master process is unable to communicate or communicating inconsistently with the LDAP process. A trace would turn that up. An all debug or -1 would also turn that up. If we turn on debugging at level 2, this returns packet handling information, how the packets between the client and server or clients and server are handled. What those packets look like will be reflected if we turn on option 2. Now notice the numbers are doubling. 0, 1, 2. The next level up is 4. This is a heavy trace. It's like option 1, but it returns even more trace information. It's even more granular. It's even more verbose. So more verbose than log level 2, or log level 1, that is. 8 returns connection management. As we've mentioned, LDAP keeps track of the connections to and fro between the client and the server. That connection information can also be dumped to the screen if we enable debugging at level 8. And in the interest of saving time, we'll just keep enumerating. At level 16, we get the packets that were sent and received. So packets sent and received. And if time permits, you should certainly experiment with these different debugging levels in your LDAP configuration to see what information is presented. But as a warning, you shouldn't leave debugging on during production, as it tends to impact performance negatively. At level 32, if you're having some sort of search filter processing problem, this is the level that you'd like to debug at. 32. This picks apart or breaks down any searches that are submitted to the LDAP server. Let's update our startup option for a moment here and perform a search. We'll update from 0 to 32, save changes, and then restart the service. Server will be back up momentarily. Not much information is returned. Then we'll execute an LDAP search. And in addition to the objects that are returned, which is the default behavior of LDAP search, we see each step of the search returned. We see everything that LDAP search is doing. It checks to see if the get filter, which gets objects from the DIT, is present, and it is. And it performs the various searches through the tree from the top level to the bottom, and then eventually it dumps the information to the screen. If a search fails, for example, supposing we search a non-existing OU, OU equals staging, then the search attempts and it returns what we would expect, which is it was unable to find. Get filter, 0, search result, nothing, no such object. It was unable to return it. So if you're having problems with a search, turn on debugging at 32 and try to process what slapd returns. Try to make sense of it. You can always take the information that's dumped to the screen and Google it to see if others have experienced a similar problem. At level 64, we get information related to the processing of the configuration file, or config file processing. This means, of course, slapd.conf. So how exactly the slapd processed or dealt with the directives in slapd.conf is returned at level 64. Let's modify using nano, upping it to 64, resetting the buffer, and then restarting slapd. As the server starts, we will see the processing of each line. If there is a problem, it will be returned. If there's an error, for example, let's purposely create a problem. So task, purposely misname a slapd.conf directive. We'll pick any directive and just change the name to something illegitimate. Let's nano etc open LDAP, slapd.conf, and we can take anything, a rootdn, for example, or a replica directive, or anything that makes sense. Rootdn. Let's make this rootdns. Let's say this was an inadvertent change. At this point, we'll restart. And as slapd starts, it will encounter an error at that particular line. So as it reads through the lines, it gets to rootdns, and all of a sudden it realizes it doesn't know the directive. So as a result, the server is unable to start. Now, had we not turned on debugging at this particular level, at 64, we would have not been able to restart the slapd service, but we would not have known why. So for example, let's turn off debugging. By setting it to 0, you can leave it with 0, that's fine. It simply means debugging off. And let's reset the buffer and then restart, or attempt to restart, slapd. Now this will attempt to restart the server. And notice it just simply returns with an error. It doesn't tell us why it failed. If you tail local messages, the default log file, you'll get some hint as to why the server failed to start. But it still isn't clear as to exactly why the server failed to start. But with debug mode 64 turned on, we know exactly why it failed to start. The next level up, as you may have guessed, is 128. 128 focuses on ACL processing. So anything pertaining to ACLs, if you write ACLs and want to debug whether or not they're legit, then turn on debugging at 128. 256 provides statistics for the logging of connections, operations, and results. So searches, internal operations, and connections to and from the server. It gives you considerable statistics about those types of functions. 512. This provides statistics about the entries sent. So as queries are made against the server, results are returned, whether failed or succeeded. And those results can be summarized, and we can witness the statistics, make use of the statistics based on option 512. At 1024, the LDAP server prints the comms or communications with the shell backends. So if you want to see how LDAP is interacting with your backend shell, meaning when slapd or the LDAP main process launches, it is a process running in the background, not connected to a terminal, but it still makes calls to the operating system via the shell, albeit in a hidden backgrounded session. We can see those communication streams if we turn on debugging at 1024 again. This is if we suspect some sort of problem, such as a bottleneck, a performance problem between slapd and the OS. And at 2048, the LDAP server prints entry parsing debugging. So how items are parsed is returned, and these are the levels of debugging that you may enable, both on the command line as well as in the main slapd.conf. Now, so far we focus in on how to implement level logging on a SUSE system. So as a separate task, we'll set up syslog logging on the RH or Red Hat 5 box. And this will simply entail updating the syslog.conf file to include the reference for local 4 to be sent to a specific file. So we'll update this file to resemble the following: local 4 star, so facility local 4, all messages at local 4, to be sent to var log ldap.log. And we can set up log rotation so that the file is rotated when a certain threshold is met. Let's modify etc syslog.conf. Red Hat continues to use the older syslog as opposed to syslog-ng. And right beneath this local 7 area, we'll paste in local 4. And for the sake of consistency, we'll tab it over to the right, although as long as you have one or more white spaces, you're fine. And when syslog is restarted, a varlog ldap.log file will be created. etc initd syslog or service syslog restart will do the trick. And now the LDAP server on the remote side will log entries to that particular file. If you don't see logging immediately, you can try restarting the LDAP server on the Red Hat box. And as a separate task, set up syslog logging on Solaris box. And the configuration is almost identical. etc syslog.conf. The entries are identical. The only difference is we use a different utility to restart syslog. Let's find our Solaris window, and we'll nano etc syslog.conf. We can search for local. Nothing's defined, so somewhere in the document we'll place local 4 dot star and just tab the entry to the right so it takes it. Now in Solaris, the utility is called, the service management utility is called service admin, SVC admin. But as we've mentioned, etc initd stores entries for the various services. Now a quick way in Solaris to enumerate the services under its control, in addition to running from etc initd, is to run the services command. Services enumerates all of the services. In this list is a reference to system log. So services grep log returns system-log. This is the syslog service, which means if we use service admin followed by restart system-log. It'll restart the system logger. Also in Solaris, sometimes it's necessary to create the log file using touch in the log directory. So if we touch var log ldap.log and then restart the service, that usually does the trick. Sometimes syslog creates the file, other times it doesn't. So to avoid any delays or missed information, touch the file, then restart your system log service using service admin. No need to memorize the options, however. Just execute service admin with no options, and you'll see the possible options: enable, disable, restart, etc. And to see a list of services, execute svcs for services. This is the new framework with Solaris 10 for manipulating services. It tells you if the service is online, offline, where to find the service, its name, so on and so forth. So we've got syslog set up for the 3 distributions. Entries will appear in them as items are replicated and as searches take place. Now, one other note on debugging in a Red Hat environment. We've mentioned in SUSE to effect the changes to startup, we modify etc sysconfig openldap. We update openldap slapd parems. In a Red Hat environment, a similar file can be created beneath etc sysconfig, but if you name it LDAP and provide a similar entry for slapd parems, you'll achieve the same effect. Or in the startup script, you can include the level of verbosity that you'd like to log with. But now at least we've set the foundation such that going forward through the rest of our studies, items will be logged in the appropriate log file, and we will be able to see what we have done. Again, we didn't reroute the local 4 file on the SUSE box because the local messages file suffices. It doesn't contain much from other services. But in the event that you are running SUSE and every local message is lumped into one file and you'd like to separate it, then strip the local 4 facility from the local messages filter and you'll achieve that result.